Okay, welcome to Chapter 3, Lesson 3, Equations in y equals mx form. Our learning target objective for this lesson is to use direct variation to solve problems. And vocabulary for this lesson. First one, direct variation. When the ratio of two variables quantities is constant, a proportional relationship exists. And constant of variation, or the constant of proportionality, the constant ratio. As always, write down, you may pause the video to write down the definitions, as we will do some examples to put these vocab words into more of a meaning for you. Let's move forward here. Okay, our key concept for this lesson is direct variation. Look at it there. Direct variation in words. A direct variation is a relationship in which the ratio of y to x is a constant, or m. We say y varies directly with x. And our symbols for this equals m equals y over x, or y equals mx, where m is the constant of variation, m does not equal 0. Here an example is y equals 3x. As we'll learn what m stands for here. So let's just move on here. So we're going to get into our examples in our y equals mx form. Our real world example, the amount of money Robin earns while babysitting varies directly with the times as shown in the graph. Determine the amount that Robin earns per hour. Okay. Just looking at the graph, you're thinking, how in the world am I going to know what Robin earns per hour? Let's look at the graph. X-axis, time or hours. Y-axis, the amount she earned. Okay, we're going to pick out a couple of points on our line. First one we're going to let's look at something that makes it easy. We're going to look at 2 right there, and that going across would be 15. And we have another easy one to pick out. Let's look at 4 hours. And it goes right across at 30. Okay, we're going to use these points now. Let's put them in y over x. M equals y over x. Our first one, we're going to look at 2 and 15, so we have 15 over 2. And our second one we have, different color here, we have 30 over 4. And 15 divided by 2 is 7.5. 30 over 4 is 7.5. So, what we just used here is we just looked at, once again, going back to last lesson, proportions. Are they proportionate? The constant rate of change is proportionate because it's on a line. Now, are they proportional that way? Because remember, we divided before on our last lesson, and they were not the same, so they were not proportional. So, constant of variation, definition for here, they're constant, 7.5, 7.5, they are constant, so that means that Robin earned, what she earned was constant rate per hour. And our constant rate is the time divided by the total she earned, which was $7.50. Let's move on to our next example. A cyclist can ride 3 miles in 0.25 hours. Assume that the distance biked in miles y varies directly with the time in hours x. The situation can be represented by y equals 12x. Graph the equation. How far can a cyclist ride per hour? Okay, so what we did here is we made a table on our left-hand side. We have our hours for the bicyclist. We have our formula in the middle. And we have our hours on this side. So, seem right? That's not supposed to be hours, that's supposed to be miles. Alrighty. So the cyclist, let's look at the first line. Cyclist rode 0 hours. Plug 0 in for X. We pop out 0 miles. That kind of makes sense. So going into our next one, cyclist rode 1 hour. Put it into our formula. 12 times 1 is 12. Cyclist rode 12 miles in 1 hour. And the last one, cyclist rode 2 hours. Multiply it times 12, got us our 24 miles. So let's look at our graph over here on your chart. We're going to plot the lines. We have 0 and 0. That's pretty easy. That's the origin of our graph right there. Then we have 1 and 12. 1 and 12 right there. And our other line, we take our pairs. Here's our 0, 0. Here's our 1, 2, 12. And our 2, 24. Go to 2, go to 24. Just right about there. So now we're trying to find, our question is, how far can a cyclist ride per hour? We're just looking for a per hour rate. So we're going to try to find our M. M equals Y over X. So going up, we go up 12. Up 12 on our graph. It goes up 12. That's our rise, and we run over 1. So we have 12 over 1 for our first point. And then our next point, let's go from our point 1 to 12. We're going to go up to 224. So once again, we go up, rise. We rise up 12. We run over 1. So that is 12 over 1. So our constant rate is 12 over 1. So he goes 12 miles per 1 hour. So we found that M equals 12 over 1. And M, M represents is our slope of our line. As our line remains constant at 12 over 1. So for every 12 miles you rise, you go over 1. You run over 1 hour. Let's go on to next slide, and is our other key concept for this lesson. Is compare direct variations. As we compare direct variations, let's look at the table. We have X's, we're going up once again. We're going up by 5, up by 5, up by 5. Our Y's are changing by 1, changing by 1, changing by 1. Y varies directly with X. As remember, in our M equals Y over X. Our Y change is 1. Our X change is 5. And our equation for this line over to the graph is Y equals 1/5 X. So what's our lesson for this is Y equals MX. What does M represent? Our 1/5. And that's where you get Y equals 1/5 X. 1/5 represents the slope of the line. On the 1, it's the rise. So for every spot you go up 1, you run over 5 spots for every point on that line. Every point on the line goes up 1 over 5. Up 1 over 5. Find the constant rate of change of the line. Okay, let's look at a real world example. The distance D in miles covered by a rabbit in T hours can be represented by the equation D equals 35T. The distance covered by a grizzly bear is shown on the graph. Which animal is faster? Explain. Okay, we are going to compare. We're comparing our direct variations or our slope. Okay, our rabbit. So with the word problem, it's always good to write down, draw, whatever information you're given. Rabbit is represented as d equals 35t, distance over time. Or very similar to our y equals mx. So we can say the unit rate of our rabbit is going to be 35 miles per hour. 35 is our constant. So the rabbit's going to run 35 miles per hour. Our grizzly bear is not going to be quite as simple as, we weren't given an equation for our grizzly bear. The grizzly bear is represented by the graph to your right. So we have to come up with his constant rate, or his m, or the slope of the line. So once again, we're going to pick some points that are easy, that intersect at nice spots. We'll look at number 1 first. It goes up. It hits right about at 30 miles. So 1 hour, 30 miles for grizzly bear. And let's see, 2, go up to 2. That hits 2 and 60. So we're going to try to find our m, our slope for that one. So once again, we have our slope equals our rise over our run equals y2 minus y1 over x2 minus x1. Always I find it easier to label our points so that way you know exactly what to plug in. Always go from left to right. So our first point that we're going to hit from the left is 1, 3, so that's our 1, so x1, y1. Our next point is the 2, so x2, y2. Now we're just going to plug those into our formula that we're working with here. So we're going to have 60 minus 30 and 2 minus 1. Y and 2 minus 1. That's going to get us 30 over 1. And 30 is our y-axis. That's our miles. Our x-axis is time or hours. So we're going to have 30 miles per hour. So our grizzly bear can go 30 miles per hour. So in our question, which animal is faster? We explained our rabbit is faster because 35 is greater than 30. Okay, any questions on how we did that, please write them down or review the video as we will proceed to our next real-world example in this lesson. And a 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in a human years Y varies directly with its age as a dog X. Write and solve a direct variation equation to find the human year age of a dog that is 6 years old. Alright, we're going to let X represent the dog's actual age and let Y represent the human equivalent age. So here's our formula for this lesson. Y equals mx. X equals the dog's age. Y equals the human age. So now we're going to plug into our formula our X. Our X is 3-year-old dog. And our human is 21. And now, once again, it's an equation like we had in chapter 2. Because remember, a variable and a number next to each other, they're multiplying. It's usually sometimes the numbers in front of the variable, depending on, but still it's m times 3. And how do we get a number away from a letter? If they're together, if they're multiplying, you do the opposite, you divide them. So we divide each side by 3. We get our constant is 7. So now that we know for 1 dog year equals 7 human years. So we're going to write our equation. Now that we know m equals 7, we have y equals 7x. So m's are 7. Here's our equation. Now we're substituting our 7 in for m. That's how we got our y equals 7. So now, going back to our write and solve a direct variation equation to find the human year age of a dog that is actually 6 years. Okay, so now y equals our 7 is our constant m slope. Now we want x is the dog years. 7 times 6 is 42 years. So a dog of 6 years old, it's 42 in human years. Okay, any questions, please write them down as we will be going over examples in class, or you may re-watch the video.